Just north of the Martian equator lies a 45-kilometer-wide impact crater that scientists believe may have been the site of an ancient lake. Here at Jezero Crater, scientists theorize that its frozen soil may contain the most significant discovery of humankind: life. On February 18th, 2021, NASA's Perseverance rover started searching this crater to find out if we're truly alone. What is the likelihood of life on Mars? What would these Martians look like? And how will we send samples back to Earth? This is What If, and here's what would happen if we discovered life on Mars. As Scientific American puts it, it would take a near miracle for Mars to be sterile. Astrobiologist Chris McKay at NASA believes that Earth and Mars have been sharing materials for billions of years. Kind of like using your roommate's spice rack. What? I thought you said it was communal. Comets or large meteorites that have hit Earth may have also sent debris onto Mars. A tiny fraction of this debris on Mars could have carried the same microbes that kick-started life as we know it on Earth. But what would this alien life look like? Many scientists agree that whatever life on Mars we might find would need to be incredibly robust. With the combination of radiation and freezing temperatures on Mars, could any life form survive such a harsh environment? As far-fetched as it sounds, microbiologists have discovered many organisms that thrive in extreme environments. The tardigrade, or water bear, is a highly resistant extremophile. It can withstand heat, cold, pressure, radiation, and even a complete lack of oxygen. There are also certain types of bacteria on Earth that rapidly produce spores when faced with hazardous conditions. The bacteria can then hibernate during an extended period of drought and withstand intense ionizing radiation. A team of 1,000 geologists, chemists, physicists, and biologists worldwide have drilled 4.8 kilometers into the Earth and discovered robust life forms. Mars has a similar geological past to Earth, so looking underground could be a great place to start. By drilling into the Jezero Crater, we could encounter spores associated with a relatively recent geological era. And on future missions to Mars, we may dig deeper and uncover fully vegetative microbes. To find rock samples that might support life, NASA's Perseverance rover uses an array of lasers called a supercam. It can study the surface of Mars at a distance. One of the lasers will heat a rock sample and vaporize it. This creates a plasma that can be analyzed to understand its elemental composition. Another laser will reveal which compounds are in the dirt. If the supercam detects organic molecules or elevated concentrations of elements like nitrogen or phosphorus, the rover will head over to take a closer look. It will then scan the soil in greater detail to detect any organic material hiding in the dirt. NASA's team on Earth has only one shot at picking the right spot to gather these samples. With limited space on board the rover, only a few dozen samples can be collected. So, no pressure and fingers crossed. If all goes well, NASA plans to bring back samples known for preserving biosignatures on Earth. Biosignatures are faint molecular traces left behind by microbes billions of years ago. Once the samples are collected, NASA and the European Space Agency plan 2 missions to get them back to Earth. This involves blasting tubes of rock and soil samples into orbit to be collected by another spacecraft and then returned to Earth. Whoa, this looks kind of fun. If Perseverance's mission is successful, the discovery of life on Mars would be as groundbreaking as the discovery of DNA. In 1543, Copernicus boldly shook the status quo with his theory that the planets orbited the sun. His discoveries completely changed our worldview, no longer putting Earth at the center of the universe. Discovering life beyond Earth could be just as powerful. But not finding any life could raise more questions. Is the Earth truly special? Are we alone out here? Even if we don't discover life, these Martian rock samples will allow chemists to study the geochemistry, mineralogy, and foundational bedrock materials of Mars in detail. This could provide us with essential insights into the climate history of Mars and help us better understand Earth's climate as well. In 1976, 2 Viking landers became the first spacecrafts from Earth to touch down on Mars. They too probed for life in the Martian soil, and the results are still debated to this day. One experiment indicated that the Martian soil tested positive for metabolism. On Earth, this would almost certainly suggest the presence of life. But another related experiment found no trace of organic material whatsoever. While most scientists have not reconciled the conflicting results, the consensus is that there's no conclusive evidence of life on Mars. But several researchers disagree. Recent discoveries of terrestrial microorganisms surviving outside of the ISS indicate that life may be resilient enough for Mars. And methane in the Martian atmosphere could be a sign of microbial methanogens, a type of microorganism that produces a significant amount of methane. Stinky aliens. Mind you, it's possible that life on Mars didn't have the right conditions to start at all. Or maybe it died off from an extinction event, similar to the asteroid that wiped out the dinosaurs. Or it's even possible that we might end up finding life that was accidentally brought to Mars by one of our many rovers. Let's hope this Perseverance mission doesn't turn into a $2.7 billion facepalm. If Mars is your bag, well, have you ever thought about setting up shop there? With recent developments in rocketry, colonizing Mars might be possible in our lifetime. One day, Mars could look like this, allowing humans to comfortably live on the planet. All we'd need to do is to terraform it. But how? Well, we could nuke it. Would dropping nukes on Mars make it easier to live there? This is What If, and here's what would happen if we nuked Mars. Believe it or not, this is something scientists have considered for decades. Elon Musk of SpaceX seems to think that nuking Mars might be one of the best and quickest options to make it a place where humans could live. The idea is that we would explode thermonuclear bombs in the sky over the planet's 2 poles. This would heat up the ice caps and release carbon dioxide and water from the poles. Then the greenhouse effect would take place. It would heat up the whole planet, making the surface more habitable. So this all sounds super quick and easy. Why haven't we done this yet? It's because there's a high chance that nuking Mars might not work out the way we want it to. There are many things that could go wrong with this plan. The first problem is it's all just theory, and the theory could be wrong. That's because Mars has been losing its atmosphere for a long time. Earth's atmosphere is almost 100 times thicker than Mars's, And if we're going to live on Mars, it needs a thicker atmosphere. Some scientists think that we could release CO2 from the North and South poles, and this could make Mars's atmosphere more like Earth's. But a 2018 study published in Nature Astronomy found that even if the nukes are successful, it would only increase Mars's atmosphere to 7% of what Earth has. Even if we create more carbon dioxide in Mars's atmosphere, it still wouldn't be nearly enough to heat the planet. And the planet could seriously use more heat, since its current temperature averages around minus 63 degrees. And it would take decades for the red planet to warm up, even after it gained the extra CO2. So, in theory, this could delay humans from ever landing on Mars. Not only that, but this assumes that dropping thermonuclear bombs on the planet would go perfectly. Keep in mind, these are nukes. You know, the things that can destroy entire cities. In fact, the bombs we'd use on Mars would be 1,000 times stronger than the ones used in World War II. If a bomb exploded on the planet's surface instead of up in the atmosphere, some severe damage would occur. Not only would it completely destroy parts of the planet's surface, it would also cause even more radiation, another thing that would delay us from ever settling on Mars. It's also very likely that instead of warming Mars, a bomb could cause a nuclear winter. This could happen from the dust and particles in the atmosphere caused by nuclear explosions. They'd almost entirely block out the sun, causing Mars to cool down even more. So, nuking Mars probably isn't the best idea. And maybe we should get some humans on the planet in its natural state before we start trying to change it. Ah, Mars, the red planet, and our potential new home. Well, Mars isn't as hospitable as it sounds. It's really inhospitable. It might be a balmy 20 degrees Celsius during the day, but at night, the temperatures can drop to minus 153 degrees Celsius.
Okay, if you don't know what minus 153 degrees Celsius is, it's intensely cold. It's like minus 243 degrees Fahrenheit. It's the type of temperature that will give you frostbite in seconds. In minutes, you'll die from hypothermia. Seriously, guys, learn the metric system. Also, we do the conversion for you in the closed captions.
And if you think Uranus smells bad, well, that's because you haven't been to Mars yet. Yeah, the red planet smells like rust and gunpowder.
But when I wear my helmet, all I smell is me, and I smell pretty good. Most of the time.
Well, you wouldn't be able to breathe on Mars anyway. The planet barely has any atmosphere. Most of it is carbon dioxide with only trace amounts of oxygen. Luckily, this time we aren't sending you to Mars. We've decided to sacrifice Chase for this mission.
What did you mean by sacrifice?
I mean send. We sent Chase up to set up a base on Mars and report back. Hey, he made it! Welcome to the Red Planet.
Kinda nothing here, huh? I thought there'd be more stuff, you know, Rico? Any ideas?
I detect no breathable air, high levels of radiation exposure, low pressure and frequent dust storms. If you want to survive on Mars, you must build a habitat.
Great idea. How long will that take?
With the materials you transported aboard the Starship, I calculate it will take about 3 months to assemble a simple base.
That's not so bad. I better get moving.
Now, building a habitat on Mars wouldn't be so simple. It's got to be airtight and insulated to protect Chase from radiation and Martian dust storms. It also needs to have a sustainable life support system to manage air, water, and waste. And, of course, Chase will need to get power from solar panels.
You don't want to know where I get my drinkable water from. But I'll tell you anyways. I could extract water from the Martian soil or atmosphere, but it's so much work. Instead, I recycle water from things like sweat and pee. I just try not to think about it.
The sensors are picking up a micrometeorite headed straight for the base. Potential hazard detected.
Don't sweat it, Rico. We got enough water. Base is fine. I built it myself. Here, let me give you a tour of my crib. Welcome to the fanciest pad on the planet. Over here is where I sleep. And over here is where I eat. And over there is a window. And this is my luxury first aid corner, in case I get hit by like a dust storm. Those babies travel at like 100 km/h. They could easily slice through my spacesuit. Oh, you gotta see my Michelin star greenhouse. It's 5 stars because it's rated out of this world. It's my favorite place in the base. Only thing is, I had to build it unattached to my main living quarters because Rico forgot to include a tunnel in the first base plan. So now every time I gotta go check on my plants, I have to go outside. It's exhausting. That's why I don't bother to take off my helmet when I pop into my habitat. I'm all about efficiency. Plus, it's a lot to animate, actually. Check out these potatoes. They look pretty good. Take that, Matt Damon.
Micrometeorite is approaching the base. I calculate the chance of it striking the habitat as 87.42%.
Rico, silencio, por favor. I'm recording a YouTube video, my friend. Come on, and what did I tell you? Round the numbers. Okay, where was I? Oh, yeah, potatoes. It takes a lot of work to grow anything on Mars. Taters aren't my first choice. I'd grow burgers if I could, but we work with what we got. I keep my greenhouse nice and pressurized and at a comfy temperature of 16 degrees Celsius. And for those of you who hated the recycled pea stuff, you're gonna love this next part because as a fertilizer for the Martian soil, I use a super special ingredient, my poo. Not because I'm a sicko, but because Martian soil is literally garbage, figuratively speaking. It smells pretty bad in here. Ugh, but at least it doesn't smell as bad as Uranus.
Danger. Micrometeoroid has breached the habitat. You must go there immediately.
What? Ah, damn meteoroid. Sorry guys, I gotta go check this out.
Your helmet has sustained minor damage.
This is my favorite helmet. Rico, do I have a spare somewhere?
You have an extra helmet, but I have bad news.
What? What now?
The extra helmet is back at the habitat.
Of course it is. Are you kidding me? 3 months on Mars, and I just finally start getting this thing working, and Mars has to ruin everything. Well, at least I have tape around here somewhere. Be back in a minute. Here, this should work. Rico, how's that storm looking?
Not good. A dust storm of this type, it can last for days.
Oh, great. That leaves me no choice. If I don't make it back in time, I'll lose everything and die. And I can't die now. I just finished building this sweet, sweet bachelor pad.
It's only a 5-second walk for you to reach your living quarters.
Okay, come on. It's only 5 seconds. You can do this, Chase. You can do this. Get your head in the game, boy. This helmet is useless. I'll go without it. 5 seconds to get back home. I can handle a little bit of frostbite.
I highly advise you don't do this.
Okay, well, if I don't make it, I'll see you guys on my next adventure. Chase out.
Looks like the atmospheric pressure killed him before the frostbite could. Didn't I say going out there without a helmet was a bad idea? Yeah, don't try this on your own. And don't worry, Chase will be fine. It's kind of his thing. He dies. A lot. But he always returns for another adventure. When it comes to planets in our solar system's habitable zone, One world is too close to the sun, another is too far, and Earth is just right. But maybe things would be different if Venus and Mars simply swapped orbits. What makes these planets impossible to live on right now? What changes would they undergo when they traded places? And why would you need Jupiter to give these planets a chance at supporting life? This is What If, and here's what would happen if Venus and Mars swapped orbits. Our solar system's habitable zone, otherwise known as the Goldilocks zone, is the distance from a star where liquid water could exist on the surface of a planet. As long as conditions aren't too hot or too cold, life could be possible, just like on Earth. But simply occupying prime real estate in the habitable zone isn't a guarantee that a rocky planet is actually habitable. Both Venus and Mars orbit within this region too, and yet no life. Despite being of a similar size and with roughly the same surface gravity as Earth, Venus is too hot to hold liquid water. And dense. Its atmosphere is 90 times denser than our own, and the surface temperature is a scorching 462 degrees Celsius. On the other end of the Goldilocks zone, Mars is also quite Earth-like, except way colder, drier, and dustier. Its average surface temperature is minus 46 degrees Celsius, and it has an atmosphere about 1% as thick as Earth's. So, if we swapped things around, would Venus and Mars transform themselves into perfectly livable planets? Bringing the red planet into Venus's orbit would put it at a distance of approximately 108 million kilometers from the Sun. This would bring it halfway closer to the Sun than it was before. Being so much closer, Mars would get a significant boost in the amount of sunlight it receives, and that alone can make the surface temperature climb to a balmy 32 degrees Celsius, just like the Earth's tropics. But without a thick atmosphere or oceans, all this new heat wouldn't stay on the planet. Just like in Earth's deserts, Mars would see extreme temperature differences between day and night. The thin Martian atmosphere would make it difficult for water to stay liquid. With such a low surface pressure, water would boil at a lower temperature. Evaporation would happen much quicker. Looks like if you want to see life flourish on Mars, you'd have to take a slightly more hands-on approach. But first, let's check out how Venus is doing in its new neck of the woods. You'd now find Venus located 228 million kilometers away from the Sun. That's twice as far as it used to be. And naturally, you'd think, surely this scorching planet would be starting to cool down. Well, as it turns out, the planet's high surface temperatures have a lot more to do with its thick atmosphere than its overall closeness to the Sun. Venus has a very high albedo, which means that it reflects about 75% of the incoming sunlight. So it could be that the planet's temperature remains more or less just as hot as before. Even as the upper parts of the atmosphere slowly cool enough for the albedo effect to decrease, that would mean that Venus could now absorb a larger amount of incoming sunlight, so that temperature wouldn't start to drop all that much. Another setback on the road to becoming a life-supporting planet would be that Venus's atmosphere is mostly comprised of carbon dioxide, with small amounts of nitrogen and clouds of sulfuric acid. What you still wouldn't find nearly enough of is water. The concentration of water in Venus's atmosphere is 100 times too low for even the most resilient organisms back on Earth to survive. But since you went through all the effort of bringing both planets from one end of the habitable zone to the other, why not take things a little further? You could try terraforming the planets to make them a little more livable. One way you could increase the surface pressure of Mars would be to try releasing all the carbon dioxide found in its soil and minerals. The only problem here is that the red planet would need to reach temperatures above 300 degrees Celsius. And despite this new location so close to the Sun, Mars wouldn't ever get this hot. Besides, if you could release all of that precious greenhouse gas, it would only amount to an atmospheric pressure of about 10 to 14% of Earth's. There simply isn't enough carbon dioxide on the red planet. Even if you had been successful with that effort, you'd still be unable to breathe on Mars. One option for dealing with this would involve bringing special microorganisms to the planet that could convert the hostile Martian atmosphere into breathable air. This would be similar to what Earth was like 2.5 billion years ago. Back then, cyanobacteria converted our methane and ammonia-rich atmosphere into the oxygen-rich one you enjoy today. But ultimately, this would be a big waste of time and resources. You'd find that with Mars's weak magnetic field, it wouldn't be able to hold on to any atmosphere you could create. That would be thanks to the power of solar winds that would constantly strip away whatever atmosphere you'd managed to generate. And sitting in Venus's old orbit, solar winds would be almost 5 times as dense as Mars is used to. Way out on Venus, the question of creating conditions for life could come down to whether you could manage to form an ocean on the planet. And that would entail bombarding the atmosphere with hydrogen. As hydrogen is introduced to the atmosphere, it would react with the carbon dioxide, leading to the formation of water. Introduce enough hydrogen and you could eventually see Venus with 80% of its surface covered in water. For this to work, you'd need a lot of hydrogen. So much that you'd probably need to find a way to harvest it from a gas giant like Jupiter or Saturn, or maybe one of their moons. Yeah, I'm not sure all this planet moving and hydrogen bombarding was really worth it. You'd still be left with only one Goldilocks planet capable of supporting life. If you were to drill straight down into Mars, what would you find? Would the red planet reveal its true colors? Would you finally discover life on Mars? And how would drilling through Mars compare to drilling on Earth? This is What If, and here's what would happen if we drilled through Mars. This is the Jezero crater on Mars, and 3.5 billion years ago, it looked very different. It used to be an ancient river delta that carried clay minerals into the crater lake. It might have even hosted Martian life. Fast forward to now, and the Jezero crater has become a perfect landing site for NASA's shiny new rover. Meet Perseverance. If I were to search for past life forms on Mars, this is the place I'd start looking too. Only instead of collecting rock samples, I'd send a rover to drill through the surface. What's the worst that could happen? Did you know that Mars has Marsquakes? They're like earthquakes, but on Mars. NASA's Martian lander called InSight detected 480 of these Marsquakes in 2020 alone. Luckily, there isn't much out there to damage. For us, these Marsquakes are a good thing. They create seismic waves that our scientists can study, and based on these studies, they can theorize about the Martian interior. But you and I would be doing this the hard way. We would drill through Mars to see what secrets it holds inside. If you started drilling through the reddish iron oxide abundant surface layer of Mars, the first thing you'd discover is that the interior is not so red. But don't be surprised. In 2012, NASA sent the Curiosity rover to Mars. It landed about 3,700 kilometers from the Jezero crater. Curiosity discovered that the layer beneath the surface of Mars is slate blue? Yeah, that's because it contains high levels of silicon. Huh. And as you drill, you should continue to expect the unexpected. The next discovery you'd make is that the crust layer on Mars is thinner than the one on Earth. Remember InSight? This little lander indicated that the Martian crust is only around 20 or 37 kilometers thick. Compare that to the Earth's crust, which is approximately 40 to 50 kilometers thick under the continents. If water still exists in liquid form on Mars, it could be several kilometers inside this crust. And there are radioactive elements in the liquid mantle below the crust. These elements release geothermal heat through their decay, and it should be enough heat to melt thick sheets of subsurface ice. This geothermal heat could be why there was liquid water on Mars 4 billion years ago, even though the surface temperatures were below freezing. But enough theory, let's keep drilling. Boring through Mars would be even harder than drilling through Earth. The deepest we've ever drilled on Earth was 12.2 kilometers into its crust, and that came with high budget costs, technical difficulties, and plenty of bad luck. But on Mars, this would be an unimaginably tricky endeavor. The InSight lander tried drilling, but it encountered unexpected soil properties. The drill probe was trying to go 5 meters deep, but could only go a fraction of the distance before popping out. Then there was Curiosity. It experienced a mechanical error. The drill feed mechanism that was supposed to move the drill bit forward wasn't moving when commanded. Luckily, scientists designed a new, more human form of Martian drilling. Now, the rover uses the force of its robotic arm to push the drill bit into the surface as it spins. But don't get your hopes high about reaching the mantle of Mars too soon. It took Curiosity the entire day to drill a mere 5-centimeter hole. Based on that, going 5 kilometers down would take up to 300 years. And you'd need a bigger drill. There's still so much we have to learn about Mars, but maybe drilling isn't the most effective way to do it. Especially since we haven't gotten very far into the crust of our own planet. Mars has been on a direct collision course with Earth for weeks now. The destruction has already started with massive tsunamis and earthquakes. Now, our planet is beginning to crack and gravity is significantly changing. But how bad will this be? How could it create a new planet? And is there any way humans could survive? This is What If, and here's what would happen if Earth collided with Mars. 15 days before impact. This won't be the first time Earth has had to deal with a massive collision. Over millions of years, asteroids have rained down on our planet. One of the biggest, the asteroid that wiped out the dinosaurs 66 million years ago. Now, despite its massive impact on Earth and our history, that asteroid was only 10 kilometers wide, about the size of 90 football fields. Mars, on the other hand, has a diameter of 6,800 kilometers, and it's coming straight at us. The red planet is normally about 225 kilometers away from us, but at this moment, it's just 4 million kilometers away. From this distance, it looks like a smaller red moon is approaching us. Now, just because it hasn't made impact yet, doesn't mean we won't be feeling any of its effects. The moon affects the Earth's tides, so what happens when another massive celestial body comes near our planet? Well, the gravitational force would be so strong that Earth's crust would start to bulge and our water would be rising. It could rise so violently that multiple tsunamis become a real possibility. More on that in a bit. 3 days before impact. Okay, now at just 800,000 kilometers away, Mars is twice as far away from Earth as the Moon is. Given its angle of approach to Earth, we'd be looking at a red half moon getting bigger and bigger by the minute. But the red planet is 10 times heavier than the moon and is already tugging at everything on Earth with much greater force than the moon could even dream of. It's creating havoc. At this point, tides are rising 30 to 50 meters high. Deep inside Earth, tectonic plates begin to shift and creak, but it's going to get much worse. In 36 hours, Mars will reach the same distance away from Earth as the Moon. Then, the tides will rise 10 times higher than usual, 60 to 100 meters. Vast stretches of coastal areas and cities would be flooded. Say goodbye to Miami, Venice, and any other city near a large body of water. Millions of people will drown. There'll be widespread panic as people on Earth see Mars's relentless approach. Earth is starting to crack. Earthquakes shake the globe. Volcanoes erupt, covering the surrounding landscape in hot, molten lava. People are running for underground bunkers, grabbing any power source available. Will they make it? Well, getting emergency assistance to one disaster site is challenging enough. Now, imagine trying to do that when you've got countless disaster sites, many in remote locations. And, oh yeah, most of the planet is without power because this incoming collision has wiped out our infrastructure. Fun times, right? Well, thankfully, before the big crash, some great minds were already cooking up a solution. One company called Nuclear Technology has been developing these fantastic microreactors. These tiny powerhouses can produce between 1 and 20 megawatts of thermal energy that can be used as heat or converted to electricity. Microreactors can be deployed and removed quickly, making them perfect for emergencies. But here's where it gets even cooler. Nuclear isn't just developing any old microreactors. Hailing from Mount Olympus and Valhalla, their projects are Zeus and Odin. I guess when you're dealing with world-changing tech, you name them after Greek and Norse gods, right? Zeus, the solid core battery reactor, and Odin, the low-pressure coolant reactor, are the perfect duo to save us from this doomsday scenario. But we don't need to go to these extremes to see their benefits. You see, these microreactors are helping us tackle real crises today. Their small size and portability make them perfect for remote communities that lack access to the central power grid. Plus, they can help our fight against arguably our biggest crisis right now, climate change. Microreactors can significantly reduce emissions from electricity production by providing a zero-carbon alternative to coal, oil, and natural gas plants, ensuring a steady power supply without the intermittency issues of solar and wind energy. But nanonuclear energy isn't stopping there. They're thinking big by going small. They're working on becoming a vertically integrated company, covering everything from cutting-edge portable microreactor technology to nuclear fuel fabrication and transportation. Talk about covering all your bases. Now, if you want to learn more about how nanonuclear technology is changing the world and fighting climate change, well, check out nanonuclearenergy.com. But hey, maybe climate change isn't our biggest worry right now because we have another planet crashing into us. So let's get back to that, shall we? 4.6 billion years ago. Okay, wait a minute. Before we get into what happens next to Earth, how did we get here? What sent Mars hurtling toward us in the first place? Well, Mars could have been pushed out of its orbit by a rogue planet. This is a planet that exists without orbiting a star. There are billions of these kinds of planets roaming around our universe. They're sometimes hard to detect though. Why? Well, because they don't give off a huge amount of light, and the light they do reflect is at wavelengths that are incredibly hard to detect. So, it's possible a rogue planet could have entered the solar system undetected, shoved Mars from its current orbit, and here we are. And like I said earlier, it's not the first time a planet the size of Mars has collided with Earth. About 4.5 billion years ago, just after the solar system formed, baby Earth and a Mars-sized planet crashed into each other. You can see it today. The debris from the collision eventually formed the Moon. At this point, people on Earth are in a frenzy, trying to find shelter from this terrifying catastrophe. But violent quakes shake the ground and toss people about. Tsunamis rage and millions of people are drowning. Wherever they can, people are running to underground shelters, hoping for some level of protection. Mars is just 10,000 kilometers away. The gravitational force of Mars and Earth are pulling at each other intensely. Mars is starting to pick up speed, reaching 10 kilometers per second. What's happening now is incredibly interesting. As it's making its way toward Earth, Mars is starting to crack. Why? Well, Earth has 10 times the mass of Mars, and because of this, our planet is exerting gravitational pressure on Mars, causing it to break. Now, there is a possibility that Mars crumbles entirely from this pressure. Maybe the people of Earth live to see another day, but unfortunately that's not likely to happen. Because Mars is moving so fast, there's not enough time for Earth to break the red planet apart. What happens next isn't going to be pretty. 20 seconds before impact. If you looked up now, Mars would be filling up nearly the whole sky. It's now just 200 kilometers above Earth's surface. It's entered the upper reaches of Earth's atmosphere. An enormous shock wave has hit the atmosphere. Due to this, you're finding it hard to breathe. Mars's gravity is pulling at our atmosphere. But that's nothing compared to what's coming next. Cracks in the surface of the Earth will be widening, creating massive canyons. The biggest earthquakes ever don't hold a candle to this. Buildings crumble and entire cities will be reduced to rubble. If you're on Earth as this is happening, well, there's not much you can do. Just hold tight for what's about to happen. Moment of impact. As Mars makes contact with Earth's surface, gravity will be about 30% of what it usually is on the side of the Earth where the crash happens. That's because Mars's gravity is 40% of Earth's, and it's pulling in the opposite direction. Both planets' gravitational forces are now pulling at each other at the same time. But that's only on one side of the planet. On the other side of the world, people will actually be 3% lighter right before they die. Thanks, Mars. That's just when people want to lose weight. Now, at the moment of impact, a massive amount of heat is generated, the equivalent of billions of nuclear bombs exploding. After the initial collision, these two rocky planets briefly separate, but that doesn't mean the battle is over. They'll eventually come together again and re-collide. Now, with the amount of heat generated, both Earth and Mars will get liquefied. A shock wave will rock Earth, reverberating through the entire planet, all the way to the other side. Within 20 minutes, everyone on Earth would feel the impact. And everything on the surface of the planet will burn, creating a mass extinction that no living thing could survive. Earth's surface will crack open down to its core. Mars will have broken apart. Large pieces of Mars's core will embed themselves into Earth's core. The entire top layer of the planets will be molten lava, and our two mantles will be mixing together. The energy from the collision will change the speed of Earth's spin. We might spin faster or slower, we don't know. And molten debris from the crash gets ejected into the sky. Smaller bits will fall back to Earth as molten lava, while the larger pieces will start to orbit Earth, forming a ring. Some of the debris will collide with the Moon, and some will be ejected further into space, hitting Venus and the asteroid belt. Over millions of years, the debris collisions with the moon will make the moon bigger and heavier. After the collision, part of Mars will be incorporated into Earth. Earth will be slightly heavier. Now, since Mars is 10% of Earth's mass, well, maybe Earth would weigh about 5% more than before. But this new Earth will be devoid of life. Could life ever emerge again on what was once our blue marble? Well, without an atmosphere and without water, it's hard to see how this would happen. Maybe in the future, comets will crash into Earth delivering water, and over billions of years, life might begin again. But with the sun getting hotter and hotter, it's likely going to boil off that water within the next billion years. Prospects for new life on Earth don't look promising. Congratulations! You've taken the 7-month-long journey and have finally landed on Mars. And it turns out, you're the first person. Better start cleaning the place up and getting it ready for human colonization. Will you ever make it back to Earth? How will you gather resources for survival? And will this happen someday? This is What If? And here's what would happen if you were the first person on Mars. A trip to Mars might happen sooner than you think. NASA is hoping for it to be as soon as 2033. Think about that. The first person on Mars might be watching this video right now.
Hello, future Martian.
And NASA may not be the first to get there. There are plenty of other space companies trying to get to Mars around the same time. Similar to what we saw in the 1960s with the moon, it's very likely that we'll see another space race, only to Mars this time. But getting there is the boring part. Now that you've landed, what happens next? Your first goal will be to set up base. And it can't just be anywhere. Researchers believe that the best place for a camp on Mars is near the planet's poles. There, you'll find massive ice deposits, which are thought to contain large amounts of water. We need water to survive, but it's heavy and it takes up a lot of room on a spacecraft. So, to solve this problem, we could potentially turn this ice into water that we could drink, study, and use. Scientists suspect that the ice deposits may also contain iron and sulfur, which could be used for manufacturing in the future. But that's in the long term. For now, let's worry about your base being built. Luckily, you won't be building it, as space companies intend to send a team of robots up there to assemble the base for you. After that's done, you can finally move in. The base will be roughly 12 meters high and 5 meters in diameter. That may sound pretty roomy, but you won't be alone. Space companies are planning to send 6 people to Mars for the first expedition. At least you'll have people to talk to while you're there. Once you've landed, you'll quickly notice how different Mars feels from Earth. Mars has just 1/3 the gravity that the Earth has. NASA says that a person who weighs 45 kilograms on Earth would only weigh about 17 kilograms on Mars. You'll be able to jump all around the planet. But if that's all you expect to do, this trip won't be for you. The first people on Mars will be unlike any astronauts we've seen before. Apart from knowing everything about physics and spaceships, they'll also have to be farmers, botanists, and excellent problem solvers. One massive problem they'll all need to solve? Food production. Let's hope you like your vegetables, because aside from astronaut food, that's pretty much all you'll be eating. A university in the Netherlands simulated crop growing on Mars and found out that potatoes, peas, carrots, and radishes could all grow on the planet. You'll be able to use the soil on Mars, and water will come from recycling urine and whatever other water products were brought onto the planet. And speaking of human waste, unfortunately, you'll have to use your poop to fertilize the crops you're growing. Now that's recycling. After about 9 months of researching, farming, and exploring Mars, you'll then begin your journey home. This is arguably the hardest part of the trip. You and your crewmates would hop into this Mars Ascent Vehicle, or MAV for short. Then, you need to line it up perfectly with the larger spaceship, which is orbiting Mars. The ascent up to your spaceship could last as little as under a half an hour, or it could be several days. It all depends on whether you can line up the MAV with the larger spaceship. And if not done correctly, things could go very, very bad. But if all goes according to plan, think of what you've just done. You were the first person on Mars. And after living there for months, what you've learned will make it easier for future generations to live on the red planet. Permanently.
It's one of humanity's most ambitious undertakings, created to extend human exploration to the farthest reaches of our solar system.
The next step in space exploration isn't generations away. It's happening right now. And our destination? That mysterious and desolate world next door. Mars. Imagine starting life over on that tiny red dot, over 265 million kilometers away. What would happen if we built a city on Mars? Would you have to live underground? How many people would you live with? And what would the Martian economy look like? This is What If, and here's what would happen if we built a city on Mars. Since 1975, the only things from Earth making claims on Mars are robots and satellites. But now, Elon Musk and his company SpaceX are looking to change that story. Their goal? To create a city with a government, trade, and culture on Mars. This plan involves 1,000 spaceships and even more brave new recruits. By surviving in lower gravity with fewer people and only limited supplies, living on Mars might change how we could adapt to dwindling resources on Earth. But with so much depending on the early stages of planning and supply runs, could life on Mars be sustainable? Every great city starts small, whether you're talking about the little fishing town of Hong Kong or a hut village named Rome. So, if you want this Martian colony to grow into a thriving city, you're going to need more than a handful of people. According to the Bordeaux Institut National Polytechnique, you would need at least 110 settlers to start this adventure. The SpaceX plan starts with 2 spaceships carrying 100 people each. With this handful of explorers, your city would have just enough people to build more habitats and research stations without putting your resources in danger. If you run out of food at this stage, that's the end of the experiment. The biggest challenge this city faces is becoming sustainable without relying on regular shipments from Earth, which will only come every few years. You see, with the egg-shaped orbit of Mars, it takes 687 Earth days to make one Martian year. Supply runs would only launch when Earth and Mars align, which happens every 2 years, to cut down on travel time between our worlds. And after this nearly 8-month-long trip, there's still a chance of losing all those supplies when the rocket lands. Since the gravity on Mars is only 3/8 of the pull on Earth, landing safely on the surface of Mars would be dangerous. And that doesn't take into account the amount of dust flying in the air. After all, the dust on the moon was bad enough, and it got into crew members' eyes and damaged systems on their spacecraft. But kicking up the dust on Mars might be even more deadly, since each grain is highly oxidized and electrically charged. But hey, you made it to Mars safely. Now, what are you going to eat? The chlorinated soils on Mars are toxic, and if you ingested them with your food, you might damage your thyroid gland. So that means farming is out. Outdoor farming, at least. Well, before you worry about eating, you'll need to set up protection from the harsh conditions on Mars. With an atmosphere made of 95% carbon dioxide, the air on Mars is toxic. And don't forget about the intense radiation on the surface. With more exposure to radiation and no breathable air, you won't be able to survive without a controlled environment. Thankfully, with the help of those rocks under your feet, you have all the protection you need. Just 5 meters of the surface materials on Mars, called regolith, provides the same amount of shielding from radiation as Earth's atmosphere. This material would be processed into cement to create layered walls using robots and 3D printers. This material would be a protective shell, and underneath that shell, domed science facilities, living spaces, and all your home comforts. Connected by tubes, these domes would provide you shelter from the raging dust storms outside, which might last for months. Even with this technology, Elon Musk claims it could take up to 10 years to establish a colony. But it's during this time that your quaint Martian village would grow into the first human city beyond Earth. Since this world isn't being drilled or fracked, the power grid on Mars can be made sustainable right from the start. We would set up solar arrays for electricity and use natural gases like methane for engines. Our footprint on Mars could start low and stay that way, no matter how many people live there. And now you better figure out a way to feed all these people. The low gravity on Mars might decrease your muscle mass. To keep your body healthy, you'll need to provide more protein. You'll have to serve the equivalent of 110 cooked chicken breasts and 660 carrots every day. If one of these domes contained an indoor farm, you could raise the chickens you need to feed your city. And you would have the most nutrient-rich manure available. If you used this manure in the greenhouses, you'd have a way to fertilize your crops year-round. But how could you irrigate those crops? How would you get water? Scientists still debate whether liquid water exists below the ice caps on Mars, but if it does exist, that freshwater source could be filtered for the colonists to use for irrigation. With less gravity on Mars pulling water down into the ground, you would need less water to keep your plants alive than you would on Earth, since it would stay closer to the surface. And with supplies being transported only every 2 years, having spring water available on Mars would change how the city would operate. It would create a government infrastructure to distribute and oversee the water supply and employ scientists to manage the filtration needs. Now, the city has an infrastructure in place and jobs to fill, so how would you value your time in terms of cash? How could you pay for products or services? Cash weighs too much to travel with in outer space, and credit cards would require Wi-Fi services communicating back to Earth. With a 14-minute gap in communications between Mars and Earth, you're gonna need something more locally based. Well, you might have to use a cryptocurrency known as Mars coin, but you would have need to have bought it with your Earth money before you boarded the spaceship. While Mars coin would only be available to Martians, this money would help build the government, increase trade, and create a standard of living. With society on Mars still new, maybe you could trade your services or learn to barter goods instead of relying on this cash system. If we do things right, life on Mars might be the model for future civilizations, free from the constraints of the culture built on Earth. Or it could be like every sci-fi movie ever made. It's been 100 Earth years since you settled on Mars. You've been through pain, loneliness, and a lot of hard work. And now, Mars is the new promised land everyone dreams of. But how did you get there? How would you find clean water and air on Mars? What would you have to do to make Mars self-sufficient? And how long before everyone can afford to travel to Mars? This is What If, and here's what would happen if you spent 100 years on Mars. It all started when SpaceX founder Elon Musk imagined that 1 million people could be living on Mars within 100 years.
I reinvented electric cars and I'm sending people to Mars in a rocket ship.
Well, Mars has been a worthy contender for Planet B since 1960, when uncrewed missions began. It's got the same day rhythm as Earth and carbon dioxide for plants to do photosynthesis. Mars has 38% of Earth's gravity and 1% of its air density. It gets 44% as much sunlight as Earth. These wouldn't be the conditions you're used to, but it would be a start. So you packed up and got yourself a job on the first base on Mars. And not just any job. You would be the first person to set foot on the red planet. 100 years in, what milestones of civilization would you see? To go on this dangerous interplanetary voyage, you'd need to be an astronaut. You'd spend years in training before you could even board the shuttle, but you made it. Yes! And now, it would be you versus Mars. You'd land in the surroundings of the Jezero crater. That's where the Perseverance rover touched down in 2021 to check out the territory before your arrival. You'd be doing some research and reporting back to Earth. The connection wouldn't be great. You'd have to wait up to 22 minutes for communication signals to get to Earth. Eventually, you'd witness the first cargo ships arriving with supplies. A few years after your arrival, the first batch of settlers would appear. Everything they'd need would be ferried from Earth, and it would cost hundreds of millions of dollars to feed each person, so you'd need to start thinking about how to make the settlement self-sufficient. First order of business, water. The settlers would start the mining of water ice near the base. You would see the first human base set up on Mars. It would be named Mars Base Alpha, just like Elon Musk wanted. You and 170 other astronauts would live there. Robots would be taking care of the initial prospecting and construction. It would no longer take 20 minutes to receive communication signals from Earth. That's because your settlement would set up 2 constellations of Starlink satellites orbiting Mars. More people would arrive from Earth, another base would be underway, and finally, the very first child would be born on Mars. But could this Martian child ever visit Earth? How would their bones and organs survive in Earth's gravity? Mars Base Alpha would become a full-fledged settlement. You would see many more firsts. The first school, the first cultured meat farm, and even the first luxury hotel. Public transport would connect Base Alpha to mining sites. Every few years, ships would arrive, each carrying 100 passengers. The settlement would begin building its first dome city. It would be a 1.6 kilometer wide impact crater covered by a transparent radiation filtering dome. It would need Earth-like pressure and temperatures so the settlers could finally take off their spacesuits. At this point, the population of Mars would reach 200,000. With advanced medical technology, your life expectancy would increase. You would finally be able to visit your friends back on Earth. It wouldn't be so easy for those born on Mars. They would need to use exoskeletons to survive Earth's heavier gravity. Wealthy people from Earth would come to Mars on vacation. An artificial magnetic field generator would permanently protect the Martian atmosphere from space radiation. Mars would now have 5 dome cities. The largest among them, Mars City, would be home to 60,000 people. Soon, the first elected city council would take office, and the first university would open. 1 million people would permanently live on Mars. You and your fellow settlers would be on pace to terraform the planet. You would release controlled amounts of greenhouse gases to thicken the atmosphere and cause the temperature to increase. You'd accelerate the process by establishing fish farms and releasing cyanobacteria that would start photosynthesis. There would be a rising tide for independence in Martian cities. Martians might not be too keen on staying controlled by the Earthlings. After all, they'd have 100 years of history to be proud of. Mars Base Alpha would become a national heritage site, and hyperloops and suborbital shuttles would connect major Martian cities. Eventually, the dream of terraforming would come true. Fresh water would flow in the once lifeless Martian surface, and settlers would finally be able to breathe in lungs full of fresh Martian air. Martians might really exist in the future, but instead of the aliens of sci-fi movies, Martians would be humans born and raised on Mars. And in this episode, you're one of them. Why would your skin be orange? Would you be a different species? And would you ever be able to visit Earth? This is What If, and here's what would happen if you were born on Mars. Some of our previous episodes have already looked at what it would take to live on Mars, but that's only half the story. To create a stable settlement on the red planet, people would have to start having babies. How many people would we need to create a healthy, non-inbred population? Well, some say we'd only need 98 people, but others say we'd need a minimum of 10,000. But regardless of the size of the breeding population, it would only take a few generations before we started seeing a huge difference between Earthlings and Martians. Mars is the most Earth-like planet in the solar system, but it's not exactly like the Earth. Its gravity, atmosphere, and magnetic field would create serious challenges for human life. And challenges often go hand in hand with evolution. Children on Earth are born with up to 120 genetic mutations. Move those babies to Mars, and they would start having mutations suitable for Martian living. And those mutations would likely pass on to their children. By the time we settle on Mars, we'll probably have the ability to modify our own genes, putting Martian evolution on the fast track. So, if you were born in the third or fourth generation of Martians, you would be a lot different than you are today. But what are the main reasons why your body would change? Well, first, there's gravity. Mars only has 1/3 of Earth's gravity, so your bones wouldn't experience the same force. Your bones would lose their density and become more brittle. Breaking them would become a common issue. Then there's the atmosphere. On Earth, you're used to a dense atmosphere that mostly contains nitrogen and oxygen, but on Mars, you'd be experiencing a thin atmosphere that's mostly carbon dioxide with only trace amounts of oxygen. You wouldn't be able to evolve a whole new respiratory system, but you could develop other ways of dealing with the lack of oxygen. Like you could have denser capillaries that are more efficient at moving blood and transporting oxygen to your muscles. But even with these advances, you'd still have to live underground or in a thickly insulated house to survive the harsh atmosphere. And since life on Mars would be confined to small spaces, Martians wouldn't need to be able to see far into the distance. Yeah, you would be born nearsighted. And finally, there's the radiation. Earth has a strong magnetic field that protects us from lethal solar radiation, but Mars has a weak magnetic field that's scattered along the planet. On Earth, our bodies produce melanin. It protects us from the radiation that does make it through Earth's magnetic field, but the radiation on Mars would be much stronger and melanin just wouldn't cut it. Instead, your skin would produce carotenoids. This pigment would help protect you against skin cancer by slowing or stopping the cell cycle. Carotenoids can even make melanoma cells self-destruct. They're also what gives carrots their vivid orange coloring. Yeah, in other words, your skin would be orange. So, with all these changes to your body, would you be able to visit Earth? Well, Mars wouldn't have the same type of bacteria and viruses that the Earth does. So your immune system would be weaker than that of an Earthling's, which means Earth could be a dangerous place for you. And even if your immune system were strong, the gravity of Earth would be too much for your brittle bones. If you were born on Mars, you'd probably have to stay there. Humans have looked the same for a very long time, but within a few generations of living on Mars, we could have orange, nearsighted humans who could survive on less oxygen. And once we successfully settle on Mars, we probably wouldn't stop there. In the future, humans could have settlements on all sorts of planets, even outside the solar system. A million people on Mars by 2050. This is just one of the bold claims that Elon Musk has made about a mission to Mars, and as exciting as it might sound, it's a flat-out lie. And it's not the first time Musk has made an outrageous claim about Mars.
Eventually you can transform Mars into an Earth-like planet.
In this video, we'll cover various statements he's made over the years about the red planet, from Martians not having to worry about radiation to how dropping nukes would be a good idea. And we'll tell you whether these claims are true or false. Then we'll imagine a world where this could happen one day. Number 6. A million on Mars by 2050. In January 2020, Elon Musk told us he'd have 1 million people on Mars by 2050. Okay, well, how would he pull this off? Well, he broke it down for us on Twitter. Yeah, it was still called Twitter then. Elon told us that he'd build a fleet of 1,000 starships. This is the super rocket that's getting us to Mars. Each starship will carry 100 people, and if all of them took off one after the other, we'd have 100,000 people landing on Mars in no time. Repeat this process 10 more times, and that's 1 million people on the red planet. Okay, that was simple. But wait, it wouldn't actually be this easy. And there's one big reason. To use the least amount of fuel, we can't just fly over to Mars whenever we want. No, we have to make sure we're timing the trip properly so that Earth and Mars sync up geographically speaking. Why does this matter? Well, since Earth travels around the Sun faster than Mars, SpaceX would have to fire starships off at a point when Mars is slightly ahead of us. And this special window of time only occurs once every 26 months. So over a period of 21 years, we'd have 10 launch windows. In each launch window, we'd need to fly 100,000 people to Mars. And remember, each of our starships can carry just 100 people. So in order for Elon to reach the magic number of 1 million people by 2050, well, we'd need to start by getting 100,000 new Martians on the planet by 2029. And isn't that coming up pretty quick? Well, when you think about it, it sounds even more ambitious when you realize we've yet to set foot on the planet just a single time. This plan also requires SpaceX to have thousands of reusable starships, and we don't even have one right now. I mean, SpaceX is trying to get to this point, but they're a little behind schedule. In 2021, Musk said a Starship would have flown in orbit many times before 2023. Yeah, not quite. SpaceX only had its first successful Starship launch in 2024. In 2020, Musk said humans would land on Mars by 2026, or if we were lucky, in 2024. Well, it's highly unlikely we're going to meet that deadline. Musk has now revised his prediction to setting foot on Mars by 2029, and fingers crossed on that one. But it's not all bad news. Okay, the first 2 starships exploded, but the 3rd starship had a successful test flight in March 2024. It did disintegrate during re-entry, but SpaceX's Falcon 9 rocket is reusable, so that's promising news for a future trip to Mars. Now, to make 1 million people on Mars by 2050 a reality, well, the following things will need to happen. Figure out how to make the starships reusable so they don't burn up on re-entry, and then build 1,000 of them ASAP. Before 2029, send a couple crews over to set up a base that can accommodate 100,000 people. Next, find 100,000 able-bodied humans who want to live in a cold, low-gravity environment for potentially the rest of their lives. Then do that 10 more times while launching thousands of spaceships and spending trillions of dollars. Sounds easy, right? Well, that's not all. There are a lot more claims from Musk that we need to worry about. Number 5. Gravity won't be an issue. Okay, living on Mars is one thing, but there are a ton more issues to worry about when it comes to flying over there. One of them is gravity. Elon recently tweeted that Starship will be able to provide a bit of gravity during flight by having a small spin on the ship. Is this a viable way to protect future astronauts? And why does this even matter? Well, as far as we know, all of human evolution has taken place on planet Earth, so our bodies have developed to work best in the gravity found on our home planet. And Mars's gravity is a lot different from ours. It's only 38% of the surface gravity we have on Earth. But that's just on Mars. We also need to worry about gravity on the ships that will be getting there, and Starship would have 0 gravity. We know from previous missions to space what that does to the human body. A 0-gravity atmosphere causes your spine to break down and get longer, resulting in lower back pain. Your muscles would also get weaker. In one study, ISS astronauts' calf muscles shrunk 13% in 6 months. Plus, the lost bone calcium might make you constipated. With less gravity, your fluids move around more easily, resulting in a number of changes to your body. Things like a puffy face, bird leg syndrome, and even damage to your eyes. And these problems have been seen in astronauts who've been in space for much shorter time periods, like the Apollo 17 mission, which lasted only 12.5 days. The flight to Mars is 6 to 9 months. Not the best side effects to be dealing with if you're the team setting up a Mars base. So gravity could be a major issue for people traveling in space for long periods of time. Elon claims he'll have a solution for this, but how realistic is it? Well, there are 3 ways to do this, each with a potentially different problem. First, a gravitational pull can be created by accelerating the spaceship, but this would use more fuel and that would cost more. Or you could spin the spaceship. The good news is that once the spin gets going, no more fuel is needed to keep it spinning, but the bad news is you'd start to feel pretty sick if you were on board the spacecraft. The only way around this is to create a spacecraft big enough that you wouldn't notice the spinning, but we're talking super big. In order to not notice any spinning, the Starship diameter would need to be 112 meters. That's the size of a football field. Now, for reference, the diameter of the Starship we have now is only 9 meters. So, unless Musk plans to dramatically increase the size, those first Martians are going to be very dizzy or have to suffer the consequences of low gravity. Another solution could be to have 2 spacecrafts, connecting them with a cable and spinning them around each other. It's a cool idea, but it's never been tested before, and remember, we've got a 2029 target to hit. Now, that's just the ride over there. What happens when humans live on Mars? How will we deal with that low-gravity environment? Well, this is something that Elon hasn't talked much about yet. Maybe he'll create spinning houses that simulate Earth's gravity, or maybe everyone will wear heavier clothes. We don't want to float away. Number 4, don't worry about radiation. Okay, now if Elon somehow does solve the gravity issue, we'd still need to worry about radiation. Musk has consistently downplayed the dangers of radiation, saying there's some risk, but it's minor. Unfortunately, we don't think that's true. Let's talk about radiation during the 6-month journey to Mars. Cosmic rays and protons emitted from the sun are two harmful sources of radiation to humans in space. When it gets deep into our cells, radiation can cause cancer. It can lead to cataracts and affect our eyesight. It can even damage our nervous system and our brains and chip away at our focus and memory. On Earth, our magnetic field and atmosphere protect us from radiation, but above Earth's atmosphere, the radiation rates are 100 to 1,000 times higher. Okay, so you're probably wondering if there's any way to fix this. Yeah, there is, but like everything else, it costs money, time, and research. Turns out water is a great form of protection against radiation. If we created a shield of about 20 centimeters of water around the spacecraft, well, we'd be all set, but water's heavy, and that would make the launch much more costly. Okay, that's the radiation on the journey, but how about radiation on the planet? Well, in addition to creating an atmosphere, it's proposed that we build an artificial magnetic shield for Mars to protect us from radiation. These are pretty complex solutions and problems we haven't quite figured out yet. We could live underground instead, but we'll talk about that a little more in a bit. These are problems that need solutions, but Musk really hasn't discussed any of them yet. Instead, he's been downplaying the radiation, saying it's no big deal.
The radiation risk is greatly overestimated.
Number 3, where will we live? Where will the Earthlings or new Martians live on Mars? Well, Musk has said that we'd likely be living in glass domes for the first 100 years or so. Now, that sounds super cool. It's exactly what I dream of when I think about living on Mars, but could this actually be a reality? Yeah, not quite. Mars is incredibly dangerous. Martians would need protection from meteorites, radiation, temperature fluctuations, and they'd need their home to be properly pressurized. A beautiful, multifaceted glass dome would be stunning to look at, but it'd be hard to manufacture, insulate, and seal. It also wouldn't provide good enough protection against these dangers. Accommodating the extreme temperature changes on Mars would be hard. From day to night, temperatures swing wildly from 3 degrees Celsius to as low as minus 91 degrees Celsius. The pressurized air inside the domes would expand and contract. Windows on the ISS have 4 panes of glass of various thickness to accommodate such swings. Creating this type of structure on the Martian surface to house 1 million people would be incredibly costly. In the short term, it's more science fantasy than science fiction. Now, the simplest way to get the best protection is to have a habitat underground. Now, this could create problems with dust contaminating the habitat as people enter and exit. It's also a lot less interesting to prospective Martians. Another option would be setting up a habitat in Mars's lava tubes. There'd be safety from the dust, except at the entrance, and the tube would provide radiation shielding and keep you safe from toxic dust and debris. Inside, you can build your ideal home. Would you like a Gothic castle in your lava tube? Now, regardless of how we live on Mars, it's safe to say it won't be a utopia-like city full of glass domes. For the first couple centuries, Martians will be hobbled underground, struggling to survive. Number 2, fission-powered lettuce. In 2017, Musk was talking about growing plants on Mars by compressing the atmosphere. No, we can't do that. Martian soil is toxic. We'll explain more on that in a second, and Musk's never really elaborated on how we could compress the atmosphere on Mars. In 2019, Musk also suggested that we could grow plants through underground hydroponics. That's where plants are grown in water with some nutrients added. This process would be powered by solar panels on Mars's surface, but there's a major issue with this claim. Getting energy through solar is going to be incredibly tricky, and the 1 million Martians Musk wants on the planet are going to need a lot of power. But due to the distance from the sun, Mars gets less than half the sunlight that we get on Earth. Not to mention the constant dust storms that often block out the sun. This would make it a lot more difficult to harvest solar energy. We'd also have to account for the higher radiation on Mars and the fact that the dust could muck up the solar panels. So Elon's suggestions about solar panels being an important source of power seem to be pretty unrealistic. Instead, a better option might be nuclear power. This type of energy comes from nuclear fission and can be unsafe, but might be our best option to generate a lot of energy on Mars. Although they'll emit radiation, we'll just make sure they're buried somewhere safe. Okay, now that we have some power, let's go back to growing our food. We wouldn't be able to grow veggies in Martian soil due to its calcium perchlorate content. This is a toxic salt found on Mars. So we'll give Elon credit and say he got that right when he said we should try to grow our plants through hydroponics. But pulling this off could come with a number of issues. For one, not every plant is able to be grown in water. Have you ever seen an apple or a pear tree growing from a bowl of water? Also, root vegetables would be harder to grow. Carrots and potatoes prefer to grow in soil. Wheat and corn also couldn't be done through these methods. I guess the Martians will be eating a lot of leafy greens. And there are some other problems with hydroponics. It's expensive to set up, and the system is dependent on power, and it needs to be micromanaged, from calibrating the nutrient solution pH to clearing up clogged pipes. And worst of all, hydroponic plants tend to pick up waterborne fungal and bacterial diseases, which might destroy your entire food supply. While we're on the topic, cows and pigs can't be grown hydroponically. We might be able to pull off growing chickens on Mars, but our best bet would be insects. Musk hasn't talked about this yet. I wonder if he'd sell us on the fact that crickets and silkworms and termites make a great pie filling. So growing food on Mars is possible, but again, the 1 million people come into question. How would we be able to grow enough food to sustain this kind of population? It's a problem that hasn't been solved yet, but Elon's next claim might be able to make all the problems we've talked about so far irrelevant. That's only if he can somehow pull it off, and I have my doubts. Number 1, let's nuke Mars. You know, it'd be amazing if we didn't have to worry about any of this, and if Mars just had an atmosphere like Earth. Well, Elon might just have the solution. On the Late Night with Stephen Colbert show, Musk theorized that he could get an atmosphere going on Mars by nuking the poles to release solid carbon dioxide ice.
Drop thermonuclear weapons over the poles.
Could this plan work? Well, we don't think so. Let's see why. The main problem with Mars's atmosphere is that there's very little of it. It has just 1% of the pressure of Earth, and it's made up of carbon dioxide. Getting more carbon dioxide into the atmosphere would make it thicker, and one way to do that is to heat the poles by nuking them. Okay, let's say Elon did this. How many nukes would he need? One estimate puts it at the entire stockpile of America and Russia. We don't think either country is ready to give up its nukes for this mission. Also, how long would it take for the radiation to dissipate? We don't know, but since this is a planet we're hoping to inhabit, we don't think this is the safest move. Unless, of course, you believe radiation is no biggie. So there isn't enough carbon dioxide to create the atmosphere we need on Mars. Could we drill into the ground to release more? Well, we don't have the technology to do that yet. And finally, even if we did get this carbon dioxide out, would it stick around? Mars lacks a magnetic field, which is a problem. The CO2 would just dissipate. All this talk of carbon dioxide is making me hyperventilate. Since humans can't survive on carbon dioxide, we'd have to get plants going to convert that carbon dioxide to oxygen. So how in the long run do we create an atmosphere? Well, before generating any gases, we need to make sure they'll stick around. For this, we need to make sure a planetary magnetic field was in place. Plus a little more gravity would help. For that, we'd need to maybe get some asteroids to Mars to increase its mass. For a few $1 trillion and some sci-fi technology, we could start working on those two items first. Nuking the planet would probably be our last and most unrealistic option when it comes to making Mars more habitable. So here's the bottom line. Will humans get to Mars? Yes, but it probably won't be by 2029, and we definitely aren't getting 1 million of us there by 2050. And sure, Elon has made some pretty outrageous claims about the planet, but he'll likely be one of the main people helping us become an interstellar civilization. Scientists theorize that many millions of years ago, Mars had rings, just like Saturn. And it looks like the red planet could be due for a new set of rings in the future. How exactly would this happen? Would these rings clutter up Martian orbit? And how soon would these new rings start raining down on Mars? This is What If, and here's what would happen if Mars had rings like Saturn. The 4 gas giants in our solar system, Jupiter, Uranus, Neptune, and Saturn, all have ring systems surrounding them. Of those, Saturn has the largest. And Mars could join the club. Scientists studying Martian moons Phobos and Deimos suggest that Mars could have had several more moons, including one up to 20 times larger than Phobos. Over billions of years, these moons could have been destroyed and become part of an ancient ring system. Could Phobos and Deimos be next on the Martian moon chopping block? Phobos is orbiting Mars only about 6,000 kilometers from the planet's surface, and it's slowly losing altitude. Eventually, it will reach the Roche limit. This is the closest a big space body can come to a planet and still be held together by its gravitational forces. For Phobos, the estimated Roche limit is 5,470 kilometers from Mars. At this point, the tidal forces of Mars would start to pull the moon apart. After breaking into carbonaceous chondrite meteorites, the stony rocks and dust would form a thin, dark ring around the planet. You'd find that the smaller Martian moon, Deimos, would still exist. That's because it orbits Mars from a comfortable 20,069 kilometers from the surface. Deimos would now mark the outer edge of this new ring. This dramatic reshaping of objects in Mars's orbit could have a big impact on any plans you could have to leave Earth and settle on Mars. Well, maybe not your plans, but more like the plans of your future descendants. Scientists expect that Phobos won't get ripped apart into rings for about 50 million years. The development of rings around the red planet would be a challenge for space flights. It would be difficult to navigate or transport people and resources. Even the most routine trips on or off Mars would become hazardous rides. And a ring system would block some sunlight, having huge effects on our human settlements on the surface. Mars is already a frozen planet with an average surface temperature of minus 63 degrees. So things would get even colder. Let's hope your descendants brought enough warm spacesuits. And even more danger would lie ahead. Eventually, all the objects in the ring would come crashing down on Mars. Big rocks would leave massive new craters on the planet's surface. If it's anything like what happens on Saturn, Martian settlers could face massive storms of rock and dust, falling to the surface at 10,000 kilograms per second. The future of humanity would depend on our ability to create new technologies to blast apart these falling objects before they crush us. Luckily for us, this would happen sometime between 1 million and 100 million years after the ring forms. Yeah, we'd have plenty of time to come up with a solution. Mars didn't always look like this. It may once have been covered in oceans. But what if we brought all the Martian water back and transformed the red planet into one that's half blue? What would Mars look like if it was 50% land and 50% water? Where would we even find enough water to fill Martian oceans? And why might we have no choice but to nuke the red planet? This is What If, and here's what would happen if Mars was half land and half water. Long ago, Mars could have been covered by a massive ocean, and there may have been rivers, streams, and lakes spreading out across the planet too. It might be that billions of years ago, Earth and Mars had similar climates. Except the Martian ocean covered only 20% of the planet compared to Earth's 71%, and the surface temperature was a bit cooler. All of that thanks to an atmosphere that didn't stick around long enough. 4 billion years ago, Mars lost its protective magnetic field, and the solar winds started to carry all of its atmosphere off into space. A few 100 million years later, Mars changed from a warm, wet world to what we know it as today. Cold and dry. Only 18% of its ocean remains, trapped in frozen polar ice caps. So if you wanted to turn Mars into a half-land, half-ocean kind of planet, you'd need to add a whole lot of water. Unlike Mars, most of Earth is covered with oceans. So what do you say we donate some of that water to our red neighbor? Well, let me tell you, that's a very, very bad idea. To make Martian oceans as deep as Earth's, you'd need to ship out about 20% of our ocean water. And this would suck for our marine life. Yeah, leave the Earth's oceans where they belong. Besides, there are a few other places in the solar system where you could find water, like Saturn's moon, Enceladus, and Jupiter's moon, Europa. They might have twice as much water as Earth, but to transport some of that precious H2O, you'd need to move massive ice blocks through space. This would be difficult to pull off, to say the least. You'd need rockets capable of transporting huge amounts of weight, and you'd need money. Yeah, a lot of it. 'Cause the price could be as high as $1,500 per kilogram. And considering how much water you'd require, well, the final price tag for this operation would be well into the trillions. Yeah, expensive, I know, but there might be another way of bringing Martian water back. And you'll love this one because it involves nukes. Yeah, you heard me right. You're about to nuke the red planet. And yes, this would give it some water. How? Well, all that energy would release frozen Martian carbon dioxide. This would cause temperatures to climb and thaw out the poles. It would be kind of like causing controlled climate change. Only you'd need to detonate around 3,500 nuclear bombs every day. And this would mean shipping twice as many bombs daily as the United States currently has in its entire arsenal. That's an enormous amount of radioactive material to release. And it wouldn't exactly make Mars habitable. Plus, you'd still need a lot more water to cover half the planet in oceans. Okay, it seems like nuking everything in sight isn't the best idea. Maybe you should take a little planetary history lesson instead. About 4 billion years ago, during the late bombardment period, a non-stop barrage of asteroids collided with Mars. This created enough water to eventually make an ocean 300 meters deep. So all you'd need to do is recreate this event today. You'd have to redirect at least 1 million comets and meteors so that they'd end up on a collision course with Mars. As the comets crashed into Mars, they'd burn up and release water vapor. Rinse and repeat until you get enough water to cover half the red planet. But where would this water go? Well, looking at Mars's topography, you'd find that all this new water would settle mostly above its equator. Mars would have new land masses that would look like continents. There would even be mountains sticking up on some parts of the planet. Olympus Mons, the tallest volcano in the solar system, would now tower high out of Mars's new northern ocean. But just because you were able to bring enough water to cover half the planet, that wouldn't mean it would last. Because of Mars's low atmospheric pressure, all this water would easily boil away. Well, wait, how would it boil away if water's boiling point is 100 degrees Celsius? Aha, well, that's the boiling point on Earth. On Mars, the water would start to boil at 0 degrees Celsius. That's frustrating, especially after all the work you put in bringing all this water to Mars. You'd have to hope that this water vapor would work as a greenhouse gas. If it could trap enough heat in the Martian atmosphere and turn Mars into a lush, terraformed world, maybe then you'd be lucky enough to be the only Earthling ever to go for a swim on another planet. What would your first 100 years on the red planet be like? Well, that's a story for another What If. Just north of the Martian equator lies a 45-kilometer wide impact crater